I've come to talk about the Internet Computer. I don't know how many of you are familiar with the project. It's the first true world computer, developed by a very large R&D operation centered in Switzerland and San Francisco. So you might be wondering about the title. If you photograph this QR code, you can actually download this deck. What's interesting about the QR code is that it downloads a deck that's served by the blockchain itself. So the Internet Computer is the first blockchain where smart contracts can actually process web requests. And that's a game changer, because I don't know how many of you are aware, but generally speaking, when you download, you interact with anything Web3, it's coming off Amazon Web Services. So there are various other pieces to this puzzle, of course, if you're creating a world computer. One of them is, how much does it cost to store something like this deck on the blockchain? Because it's all very well being able to serve HTTP from a blockchain, but if you can't store the media on the blockchain or the data on the blockchain, it's not going to get you very far. So the differences are much, much bigger than most people are aware of. This deck can be stored on the Internet Computer for 4 cents a year. Really nothing at all. On Solana, it would cost you $800 a year. On Ethereum, it would cost you $500,000 a year. Truth is, you couldn't even upload it to Ethereum, you couldn't do it. So something else you may not be familiar with, if anyone, I don't know if anyone's ever been to dashboard.internetcomputer, but the blockchain's currently doing around about 500 billion transactions a day. It's more than 10 times more than any other blockchain in existence. So the purpose of this system is to, by applying super advanced chain key cryptography, to enable what we call blockchain singularity, which is an endgame where the majority of the world's systems and services actually run from the blockchain itself. So, there's a movement. One of the biggest growing grassroots communities in blockchain. And the aim is decentralized infinity. And that's where, of course, the name of my organization, the DFINITY Foundation, comes from. One of the original crypto projects, DFINITY originally was back in sort of 2015 working on what it hoped would be Ethereum 2.0, went its own way. Did a lot of work, did an ICO in February 2017, and took till May 21 to actually launch the network. It's actually the largest R&D operation in blockchain, has been for a long time. We have the largest team of top cryptographers in the world, of any organization at all. And a lot of very famous cryptographers, computer scientists, and engineers in the organization. Okay, so since most people here are interested in Web3, what does a world computer blockchain fix for Web3? What does ICP do for Web3? So here's the central problem that blockchain faces today. When you hear somebody say that a Web3 service is built on a blockchain, it's kind of like misleading advertising. It's not really built on the blockchain at all. It's built on Amazon Web Services. And 99% of the data lives on Amazon Web Services, and the service just keeps some NFTs and some tokens on the blockchain. It's not really on the blockchain at all. And of course, the problem is, hackers, regulators, censors, vested interests, they all target that centralized piece where 99% of Web3 lives. So our mission is to put the world on chain, and we do that, we pursue that by developing the Internet Computer. Essentially, it's a network of these things called node machines that are connected by something called Internet Computer Protocol, which produces the world's only truly limitless scalable blockchain. It's powered by Moon Math, some of the most advanced cryptography in the world, certainly the most advanced cryptography in the crypto industry. And it has these incredible superpowers. So for example, if you build on the internet computer, your smart contracts can process HTTP requests, which means that they can securely serve interactive web experiences directly into the web browsers of end users. Another important game changer for Web3 is that when you build on the internet computer, it's fully on-chain, right? And as we know, that's not what happens anywhere else. When you hear about other ecosystems and you hear the word built on blockchain X, what that really means is that it's built on Amazon Web Services typically, or some other cloud, and just a few tokens and NFTs are kept on the blockchain. So with the internet computer, you can build a social network on the blockchain. You can run something like Facebook from the blockchain. There are services running today on the internet computer with thousands and thousands of users, and there's no cloud involved, there's no centralized tech, there's no servers. Now, there's a very, very important consequence of this. If you actually build entirely on the blockchain, you can put your service under the control of a DAO. And that's just simply not possible on any other platform in existence today, because a DAO is built with smart contracts, and a DAO cannot reach out of the blockchain and configure stuff running on Amazon Web Services, which of course the developer can switch off or get hacked or anything like that. So the reason this is important is Web3 is all about ownership. And the vision that we pursue is that, well, you can have something like Facebook running on the blockchain under the control of a DAO, where the governance tokens are largely owned by users. So users actually gain ownership of the services they depend on and use every day. But the only way you can do this is if you make it possible to build the entire thing, the entire Web3 service, whether it's metaverse, social media, gaming, whatever it is, the entire thing has to be built entirely on the blockchain. Otherwise, you can't put it under the control of a DAO. All right. So something else, maybe getting a bit technical, but there's a technology called chain key transactions that enables smart contracts on the internet computer to create signed transactions in other blockchains. It's just literally coming into production now. It's been running for some time, just waiting to be sort of signed off by the governance system. So for example, you can create native Bitcoin DeFi. You can create smart contracts that process Bitcoin, create Bitcoin addresses, send and receive Bitcoin, do the same for crypto assets on ETH. And there's no bridge involved, just pure cryptography. No trust, no centralization, no bridge that can get hacked, which is a big deal. Don't forget, bridges have been hacked for almost $2 billion this year. So, today, you won't hear much about it for a bunch of reasons, but there are thousands and thousands of sort of dreamers building on the internet computer. All kinds of things, in every field you can imagine. So another aspect of the internet computer, which is very novel, which you may not have heard of, is that the entire blockchain, the entire network, runs under the control of a decentralized governance system, a DAO, that's integrated into the protocols called the network nervous system. And it's a permissionless DAO, and the network itself can't fork. And it's not upgraded by a central company, like most blockchains today have a company behind them, Solana Labs, IOHK, Avalabs, whatever it is. And that centralized party coordinates the community of validators upgrading the node software. The internet computer doesn't work like that. It's fully decentralized. So it runs under the control of a permissionless governance system called the network nervous system. And people submit proposals to the network nervous system. It adopts and rejects proposals, and the adopted proposals get executed automatically. And these proposals can upgrade node machines, for example. So rather than forking to upgrade the network, people submit proposals to the network nervous system, which is an open governance system. If it adopts them, it executes them. And for example, those proposals can structure the network. They can upgrade the protocol by upgrading the software on the node machines. But it's entirely automatic. There's no centralized party involved. Another aspect of the internet computer you may not be aware of is that it runs on a sovereign network of hardware. The network model is something called proof of useful work, which is very different to proof of stake. So obviously with any kind of proof of work network, the people participating in the network have their own hardware. They own the hardware and they install it. And in this case, the network mediates participation by ensuring that the node machines are performing their role and performing any useful computations, which is one of the ways that the efficiency of the network is driven as far as it is. Very different to cloud validators running in the cloud. All right, it's green, obviously, and actually the internet computer, not only is it designed to host the world's services and systems, it's orders of magnitude more efficient than other blockchains. It's also designed eventually to reduce the CO2 emissions of traditional IT. So let's just quickly review efficiency by looking at the cost of smart contract data. These stats were taken on the 29th of September. Changed a bit now, obviously, with the markets. Okay, so on the left is a box representing the cost of storing a gigabyte on Ethereum, and on the right is a box representing the cost of storing a gigabyte on Solana. And we can see that Solana is 650 times more efficient than Ethereum. On Ethereum, it costs you $80 million to store a gigabyte. On Solana, just short of $120,000. All right, so let's look at Solana versus Internet Computer. So the difference actually is almost 1 to 24,000. And I'll actually let you know that Internet Computer box is roughly like 50 times bigger than it should be. And we had to make the difference look less extreme visually, because otherwise nobody could see the Internet Computer box. The differences between blockchains derived from advanced cryptography are absolutely colossal and unimaginably large for most people. You often hear Solana's the most efficient blockchain. Of course it's not, as you can see here. This blockchain's 24,000 times more efficient. It's also processing more than 10 times more transactions a day currently. So what that would mean, for example, is if you wanted to put a phone photo on the blockchain, it would cost you 1.6 cents on the Internet Computer, $400 on Solana. But it's not just about files. It's about structured data, the kind of stuff you find in a user profile or news feed. OpenChat's a great example. It's actually a chat system running on the Internet Computer where you can send chat messages and the smart contracts process them in real time and store them, including, in fact, media messages. There's not too much noise about the Internet Computer in the mainstream crypto press. People are very worried about it. But, there are people, thousands and thousands of developers, and they're building, new equivalents to Web 2 services, but in new ways, and they're going to decentralize them with DAOs. 3,000 plus GitHub repos. There's an assertion that software is eating the world, and we say the corollary of that is smart contracts release software. Today, centralized IT infrastructure runs the world. It also runs blockchain, right? Like all of Web 3 runs on the cloud outside of the Internet Computer ecosystem, and most blockchains also run in the cloud. Obviously, the Internet Computer doesn't work that way. Web 3 is built on the blockchain, and the Internet Computer runs on sovereign hardware. But it's worth thinking for a moment about what the opportunity is presented by the scale of centralized IT that can be replaced by world computer blockchain. We spend $5 trillion a year on IT worldwide, half $1 trillion a year on cloud services. And just to sort of drill down a bit, this year people will spend $172 billion in cybersecurity. On a blockchain, obviously the advantage is you don't need a firewall, right? You can get rid of that. If you want to know more, get into the technicalities of all this, go to internetcomputer.org. There's a lot of information there. Help us drive awareness. There are a bunch of reasons. People don't talk too much about the Internet Computer. We guess awareness now is at less than 0.1%. Imagine where we're going when people find out about these capabilities. So help us drive awareness, sort of join us in our mission. All right, that's it. Thank you.